Can all of you see the screen, yes or no?
Yes.
Okay, fine. So, okay. Yesterday we ended up with the topic was, what was the topic?
Relation between molality and molarity.
हाँ, रिलेशन बिटवीन मोलारिटी और मोलारिटी, लेकिन वो तो ऐसे आपका बीच में स्टार्ट हो गया था ना. उससे पहले हम लोगों ने क्या था, द इफेक्ट ऑफ प्रेशर, राइट. We are learning factors affecting the solubility of gas and liquids, and in that we are learning the effect of pressure. Okay, so factors affecting, we'll continue from here. Factors affecting the solubility of gas and liquid. Abdul Rahman, can you hear me?
Yes, sir.
What's going on in your school? कौन सा चैप्टर चल रहा है?
Sir, solutions.
Solutions only. इससे पहले क्या कराया था उन्होंने?
Sir, they had completed solid state.
Sad life. Solid state तो delete हो गया फिर ना? अच्छा.
Yes, sir.
Okay. So we were learning about pressure, right? We were learning about pressure, and in pressure, we saw that if I increase the pressure, solubility increases. On increasing pressure. Okay. Now, I want all of you to listen here very carefully. Just suppose we have some water here. Okay. We have some water here. Now, and there is some gas dissolved here. There is some gas dissolved here. Okay. Now, when the gas is dissolved inside the liquid, obviously there will be some gases on the surface also, right? And some gas particles from the liquid, it will be leaving the liquid and leaving the solution, and it will enter the air just above the solution, right? And there will be some particles here also, right? There will be some particles here also. These particles will be getting down and they will be getting inside the solution, right? And both of these things, it will be happening simultaneously. Yes or no?
Yes, sir.
Any doubt till here? No doubt, right? Okay. Now, we also said that in the last lecture, if you remember, that the solubility of a gas at a given temperature is directly equal to the pressure at which it was added. The pressure at which it was added. Okay. So the pressure that was added, and so these gas molecules which is above the solution, they will have some pressure, and it will be exerting some pressure on the walls, right? It will be exerting some pressures on the wall, and the same pressure it will be exerting on the surface also. Surface of water, the same pressure it will be exerting on the surface of water, right? Now we can say that if the concentration of solution is high, the concentration of the solution is high, that means the pressure that is exerted by this gas molecules, it is also high, right? The pressure is high. Yes or no? Can I say that if the concentration is high, the pressure will be high? ये बात समझ में आई कि नहीं है, ये बताइए पहले सब कोई.
Sir, can
Here
you
we
explain
have
again?
the solubility means what? Amount of solute inside the solution. Yes or no?
Yes, sir.
Solubility, that means it is concentration only, right?
Yes.
Amount of solute, and now solubility increases on increasing the pressure. Okay, solubility increases on increasing the pressure. Solubility increases on increasing the pressure. That means we can say that if the concentration of a solution is high, the pressure that is exerted by the gas in the vapor phase. So here we have the solute particle, the gas particle here are in aqueous phase, and here they are in vapor phase. Okay, in vapor phase. So we can say that if in aqueous phase we have more gas particles, then the pressure that has been exerted in the vapor phase will also be high. Yes or no? ये बात बोलिए समझ
Yes,
में आई
sir.
कि नहीं है ना? So the pressure in the vapor phase will also be high. Okay. Now, so we can write the pressure is directly proportional to concentration. Right? Pressure of what? Pressure of vapor phase is directly proportional to the concentration in what? Concentration in aqueous phase or in the solution. Okay. Now, taking the concentration term as the mole fraction, so P is directly proportional to chi of what? Chi of B. Chi of B means the mole fraction of solute inside the solution. And then we can write P, it is directly proportional to some constant K, and this was given by Henry. That is why called KH. Henry's constant. P is equal to KH into chi B. Okay. P is equal to KH into chi B. Now, this is the mathematically how we represent the Henry's law. And the statement of Henry's law, it goes something like this, that the partial pressure of the gas that is in the vapor phase is directly proportional to the mole fraction of the gas in the solution. Right? Partial pressure, you can write this now. Partial pressure of the gas in vapor phase is directly proportional to the mole fraction of gas in the solution. Okay, so this is Henry's law. The above statement is Henry's law. Is that clear till here? Isana, please tell me.
Yes.
Please write. Okay, please write this down. I hope all of you have written. Now let us look at the. Okay, what is this KH? This is Henry's constant.
1 minute, sir, can you go up?
Wait a second. Yes, done ना? आगे बढ़े?
No, sir.
Yes.
No. सैफ नहीं हुआ अभी?
No, sir.
अच्छा. Write this down fast. Henry's constant KH. Okay. Let's discuss a few things about the Henry's constant KH. सैफ हो गया अब तो जल्दी लिखिए लेकिन.
Yes, sir.
Okay. Now, so Henry's constant, first thing is that it depends on the nature of the gas. Okay. Number 1 point. KH is a function of KH is a function of KH is the function of the what? KH is the function of the gas, that is different gases please write this in me. Okay, will have different values of what? Different values of KH. Second point, as we can see that P is equal to KH into chi V. So KH will be equal to what? Pressure upon chi V. So if we take pressure as constant, then we can easily imply that KH is what? It is inversely proportional to the concentration of solute inside the solution, right? So what? Concentration. That means the amount of solute that is dissolved in the solution, and hence it is also giving me or solubility, right? Concentration, solubility, these are exchangeable words. Solubility, that means KH is inversely proportional to chi B, and we can write if KH is higher, solubility will be low. If KH of a gas is high, its solubility will be low. Its solubility will be low. Is that clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now we also see that, so that KH, it is equal to pressure upon chi V. What is the unit for mole fraction? Tell me. What is the unit for mole fraction? मैमूना बताइए. मोल फ्रैक्शन की यूनिट क्या होती है?
No unit.
No unit. Correct, Abdul Rahman. It does not have any unit, right? So the KH का क्या unit होगा? KH will have the same unit as that of pressure. You can have ATM, or you can have torr, or you can have bar, right? Okay, fine, Khalid, not a problem. Okay, ATM, torr, or bar. This will be the units of KH. This will be the units of KH. Is that right? Yes or no? Please tell me. Can I move on? Can I move on, guys? Yes or no?
Yes.
Okay. Saif, आपका हुआ?
Last point, sir.
Last point. Okay.
Sir, sorry. Can you show?
हाँ. Yes. Salman, tell me.
Can you show the app? Okay. Yeah, okay, sir.
That's it.
Done. Okay. So we are discussing gas inside liquid, right? And we have already seen that if I increase the temperature, what happens to the solubility? Solubility increases or decreases? If I increase the temperature, gas inside liquid, last class में पढ़ा था ना? टेम्परेचर नहीं पढ़ा था क्या आप लोगों ने?
Increases.
इंक्रीजेस बिहारी है क्या? बिल्कुल. डिक्रीजेस है भाई. Solubility will decrease ना on increasing the temperature. Yes or no? अब्दुल रहमान ने कहा ना ये बात. अब्दुल रहमान. Yes, अब्दुल रहमान. Hello, am I audible? अब्दुल रहमान unmute तो कीजिए. क्या हो जाता है?
Yes, sir.
मैमूना,
Yes, sir.
solubility will
Decrease with increase in
Decrease.
temperature.
increase in temperature. Okay, now what I can say about KH. KH क्या है आपका? KH is what? It is inversely proportional. KH is what? It is inversely proportional to the solubility. That means if solubility is decreasing, KH will increase, right? So you can see that temperature and kh, they are directly related, right? So we can say that what we can say, we can say on increasing the temperature, the kh also increases. So kh is directly proportional to the temperature. Okay, kh is directly proportional to the temperature. Write a question. Why are aquatic animals more comfortable in cold water than in warm water? So what is the reason? What is the reason? Tell me. Achha, aquatic animals, they will be comfortable in a place where we have more oxygen or less oxygen?
More.
More oxygen. What do you think? Where will be more oxygen? Cold में या फिर warm water में?
Cold.
Cold water, right? Since the solubility is high if you have low temperature. Since solubility is high at lower temperature, more O2 is dissolved. है ना, ये लिख सकते हैं, more O2 is dissolved. More O2 is dissolved in cold water. Therefore, aquatic animals are more comfortable in cold water than in warm water. ठीक है? So ये रीजनिंग टाइप के सवाल जो है ना, ये सीबीएसई में बहुत पूछे जाते हैं. ठीक है? So mark this important as for the board examination, CBSE. Done, guys? This one now, please tell me. Are you done?
Yes.
1 minute, sir.
1 minute. 1 मिनट लग जाएगा आपको. ग्राफ भी पढ़ा था ना, ग्राफ.
Completed, sir.
ठीक है. ग्राफ फॉर हेनरीज लॉ. ठीक है. सबसे पहले जिस चीज के भी जिस चीज का भी आपको ग्राफ बनाना रहता है, you'll write pressure, it is equal to what? kh into chi b, है ना. उसके बाद चलिए ये बताइए, what will be in the x axis and what will be in the y axis? Tell me. x में क्या होगा, y में क्या होगा? प्रेशर को कहाँ रखें? हाय हाय, प्रेशर विल बी इन द y axis. ओके, देखिए y is equal to fx होता है ना, है कि नहीं? ऐसे लिखते हैं ना. You have seen this expression, right?
Yes.
y is equal to fx, है ना. तो y जो होगा आपका generally, like if you use the mathematical relationship जो सही से लिखा रहता है, that will be always on the left hand side. ठीक है. y is equal to fx. Okay. So pressure, it is the function of what? Mole fraction, right? Chi b. ठीक है. And what type of graph will be here? You will be having graph that is passing through the origin, right? Yes or no? है ना? Graph that is a plot that is passing line that is passing through the origin. Y is equal to mx टाइप का ग्राफ है, जिन लोगों को थोड़ा मैथ्स आता है. Yes or no?
Yes.
Okay, so y is equal to mx type of graph है. What is the slope here? Slope that is m that is equal to kh. ठीक है? Slope, the slope of the plot between the pressure, the partial pressure of gas and vapor phase with the mole fraction of gas in the solution gives you the kh, gives you the Henry's constant. Slope is equal to kh. ठीक है? So this is the graph for Henry's law. Can I move yes or no? Please tell me. ग्राफ बना लिया तो बताइए.
Yes.
Okay. Write this question. हाँ जी, हो गया? All of you are done writing the question,
No,
yes or
sir.
no? No. जल्दी लिखिए, जल्दी. So the question is asking how many millimoles, what is the amount of N2 gas that is dissolved in 1 liter of water, and they have been given, you have been given the partial pressure of 0.987 bar. And that means you have been given the pressure here. You have been asked about the number of moles. So first of all, we will calculate the mole fraction, and after that we will calculate the, first of all, we will calculate the mole fraction, and then we will calculate the number of moles of N2 that is present inside the solution. So start, we will write pressure, it is equal to the Henry's constant multiplied by the mole fraction. So we have here the pressure and the Henry's constant. We will easily calculate the chi b. So chi b will be equal to the pressure divided by Henry's constant, right? kh. Now you can see that pressure is equal to 0.987 bar divided by the kh is 76.48. This is kilobar. ठीक है, तो 1000 multiply कर दीजिए. This will be equal to 76480 bar after the multiplication of 1000. And as expected, we are going to get a number that means mole fraction does not have any units. You can write 987 upon 76480 multiplied by 10 to the power minus 3. ठीक है, इसको solve कीजिए. Tell me what is the answer here. What is the mole fraction? Calculate this and tell me what is the mole fraction in the chart. 987 को when you are doing rough now, so you will make some line like this in your notebook. पीछे मत रफ कीजिएगा, same page में. Okay, same page में और same size. जैसे आप इतना बड़ा बड़ा लिख रहे हैं, then you will write, you will do the calculation like this. 987 you can write this as 990 divided by 76480. You can eliminate the 0 and the 0, and you will be getting 99 upon 7648. ठीक है. Again, I will do a bit of approximation, that is, I will take this as 100 and take this as 7650. 7650. ठीक है. So you can eliminate these two things. Now you will be having 10 upon 765. अब काफी आसान हो गया है. Please calculate this and tell me what's the value. I need at least 2 non-zero digits after the decimal point. ठीक है, एक नहीं, at least 2. कैलकुलेटर मत यूज कीजिए भाई प्लीज. मैमुना, कैलकुलेटर. यस मैमुना,
Yes, sir.
कैलकुलेटर.
Yes.
अरे क्यों भाई, क्यों कैलकुलेटर? आईसीएसई है क्या आपका? सीबीएसई है ना? हाँ मैमुना,
Yes, sir.
सीबीएसई में तो अलाउड नहीं होता ना, तो आदत रखिए. चलिए कैलकुलेट कीजिए. ठीक है, कैलकुलेट कीजिए. Yes, Salman, correct. Yes, Harith, correct. So all of you must be getting this as 0.0130. ठीक है, लेकिन आप इसी को अगर कैलकुलेट करते हैं ना, 987/764 876,480, ये आता है आपका 0.0129. ठीक है, तो ज्यादा का डिफरेंस नहीं है, एज यू कैन सी. दैट इज वाई साथ साथ जहां पे भी हमने अप्रोक्सीमेशन के साथ ना, आई हैव ट्राइड ऑल दी क्वेश्चंस एंड आई हैव डन सम अप्रोक्सीमेशन जिससे कैलकुलेशन आसान हो जाए. सो वेयर एवर पॉसिबल आई विल टीच यू वेज जहां पे आप अप्रोक्सीमेट कर सकते हैं. एंड ये सवाल जो है आपके पास कई बार आया हुआ है सीबीएसई में. ठीक है, so even if you take this as 0.130, it is not going to harm you in any way. So you have got the number of mole fraction is equal to 0.130. 0.0130. You also know that chi b, it will be equal to the number of moles of B, that is the solute, divided by number of moles of A, that is the solvent, plus number of moles of B. Now number of moles of solvent. Please remember, please listen very carefully. Don't write anything. Okay, don't write anything. Please listen. N2 is dissolved in how many liters of water? Saif. N2 is dissolved in how many liters of water? Saif.
1 liter.
1 liter. Very good. And what is the density of water? Density of water? नहीं पता. This is equal to 1 gram per ml. Okay. So
Okay, sir.
1 liter, it is equal to 1 kg, or it is equal to how much? 1000 grams. ठीक है. So 1 liter is equal to 1 kg. ये दो चीज याद रखिएगा. And 1 gram is equal to 1 ml. ठीक है. 1 gram is equal to 1 ml for water only. Okay, only for water, only for water, only for water. ठीक है. अब्दुल रहमान, आपने सवाल लिखा है? अब्दुल रहमान, have you
Yes,
written the question?
Yes,
ठीक है.
sir.
Last time पढ़िए. The KH of N2 is, पढ़िए loudly भाई.
Sir, 76.48.
पूरा पढ़िए ना. The KH of N2 is, units के साथ.
76.248
48
K bar.
K means,
Kilo.
kilo means
1000.
into 1000. समझ में आ गया?
Yes, sir.
आ गया ना? ठीक है. Okay. So 1 liter is equal to 1 kg, that is equal to 1000 grams. I think I said also यहाँ पे जब हम लिख रहे थे ना, तो आप उस टाइम शायद लिख रहे होंगे साथ साथ में. So इस नहीं सुना आपने, हमने कहा था शायद. Okay. So 1000 grams. So calculating the number of moles of H2O, that is the number of moles of solvent, that is the number of moles of A. Please don't write anything, just listen. This will be equal to 1000 grams divided by 18 grams per mole. That is the molar mass. Please remember the molar mass for H2O, CO2, NaOH, these things. Okay, H2SO4 ka bhi, HNO3 ka bhi. So 18 upon 1000, this will be equal to 55.56 moles. Okay, ये भी याद कर लीजिए. In 1 liter of H2O, there are 55.56 moles of H2O. ठीक है, अगर ये आपको याद रहेगा, it will be very helpful in competition. Competitive exams में बहुत जल्दी आपका हाथ चलेगा फिर. ठीक है, so in 1 liter 55.56 moles of H2O are present, and we also have, see, chi B, it is equal to NB upon Na plus NB, which is equal to 0.013. ठीक है, 0.013 है ना. मोल फ्रैक्शन यही आया हम लोग का. If you remember it, mole fraction we have calculated from Henry's law, and which is equal to 0.013. Now you tell me which one is greater, the numerator or denominator? बताइए क्या बड़ा होगा? न्यूमरेटर बड़ा होगा, डिनोमिनेटर बड़ा होगा? हाँ guys, what will be larger?
Denominator.
Denominator.
No? Numerator will be very small compared to the numerator. Sorry, numerator will be very small compared to the denominator. Yes or no?
Yes, sir.
And so we can write as NB is very small. NB is very small. We can say that we can ignore the NB from here. Okay. Denominator, when you see NB is very small, if you add very small to 55.56, that is not going to affect it, right? So you can ignore the NB from here. You can write NB upon 55.56. It will be equal to 0.13. Sorry, 0.013. 0.013. Okay. Right? NB is very small than, very smaller than 55.56. Okay. Now NB, it is equal to 0.013 into 55.56. This will be in terms of moles. So आपका ये भी moles में आ जाएगा. चलिए इसको कैलकुलेट कीजिए, बताइए कितना आ रहा है. Multiply this. कैलकुलेटर मत यूज कीजिएगा मैमूना. Do it manually. Send the answer in chat.
Can you scroll up?
कहाँ से चाहिए आपको?
Yes, sir, from here.
Yes, Saif correct. Yes, Mamuna correct. Khalid correct. Okay, so the answer is coming to be 0.72, है ना? 0.72 आ रहा है. ओहो, अच्छा एक सेकंड. आई हैव मिस्ड वन थिंग. यहाँ पे 10 to the power minus 3 था, है ना? यहाँ पे भी 10 to the power minus 3 होगा. यहाँ भी 10 to the power minus 3 होगा. यहाँ पे भी 10 to the power minus 3 होगा. यहाँ पे भी 10 to the power minus 3 होगा. ठीक है? 0.72 into 10 to the power minus 3 moles. You can also write this as 0.72. 10 to the power minus 3 will be milli, है ना? Moles. This is the number of moles of N2 inside the solution. Okay, Salman. What about others? Done all of you? Yes or no? Please tell me.
Done, sir.
Yes.
Write a small question. ठीक है? Solve it. Send the answer in chat. Okay, so you just need to do what? First of all, write the statement that has been given. 0.1 liter of water, है ना, under nitrogen, 1 liter of water under nitrogen pressure 1 atm dissolves 0.2 grams of nitrogen at 293. So 0.02 gram of N2 in 1 liter of H2O. ठीक है? So from here you will calculate the number of moles of N2. From here you will convert this to 1000 grams of H2O, right? So from here what you will calculate? From here you will calculate the number of moles of A, है ना? इससे मालूम मोल फ्रैक्शन आ जाएगा आपका chi B will be equal to NB upon Na plus NB. ठीक है? After calculating the chi B, when you have got the chi B, you just need to calculate what? P is equal to KH into chi B. So KH will be equal to P upon chi B, है ना? ठीक है? All of you can calculate number of moles ना from here, yes or no?
Yes.
है ना? तो यहाँ से भी आ जाएगा आपका number of moles. Then you can calculate the mole fraction. चलिए पहले number of moles of N2 बताइए कितना आ रहा है आपका? Number of moles of H2 कितना आ रहा है? ये तो आपको 55.56 आ जाएगा. ठीक है, याद है अगर आपको तो. Number of moles of B बताइए कितना आ रहा है? I think that is going to be correct only. एक सेकेंड. So NV is equal to 0.00071. ठीक है ना, बस यहाँ पे आप लोग रख दीजिए. अब इसमें ना ऐड करने की जरूरत ही नहीं है, बस 55.56 कर दीजिए. ठीक है, ठीक है. एंड जस्ट लीव इट लाइक दिस. KH will be equal to what is the pressure? 1 atm. Pressure is 1 atm. Divided by 0.00071. This is divided by 55.56. This will be equal to 55.56 upon 0.00071 atm. ठीक है, इसको क्या लिख सकते हैं आप? 5.56 divided by, so this will be equal to 10 to the power minus 4 ना, 7.1 10 to the power minus 4. ये आपका 55.56 into 10 to the power 4 upon 7.1 आ जाएगा. ठीक है, चलिए कैलकुलेट दिस एंड टेल मी. आप ये भी लिख सकते हैं 555.6 divided by 71 into 10 to the power 4. जी, yeah,
How
tell me
did
what
he
happened.
get such a small value for NB?
Number of moles will be equal to given mass by molar mass. Yes or no?
Yes.
Correct है. What is the given mass?
0.02.
Divided by
14.
why 14 भाई? N2 है ना, नाइट्रोजन है. 14 plus 14 दो नाइट्रोजन है ना. अरे my dear Saf,
It's
N2 will be
28,
equal
sir.
to 2 into 14 ना, 28 आ जाएगा. अब स्मॉल वैल्यू.
Yes.
ठीक है. यहाँ पे वी आर नॉट एडिंग ना, क्यों ऐड करेंगे, मतलब देयर विल बी नो यूज ना, इतना छोटा वैल्यू के इसमें ऐड करके कोई ज्यादा फर्क नहीं पड़ने वाला अब्दुल रहमान, है ना, इस वजह से नहीं ऐड किया हमने। ओके, वी टॉकिंग अबाउट दिस स्टेप राइट,
Yes, sir.
है ना, दैट द 0.0071 ऐड करके भी कोई फायदा नहीं है, दैट्स व्हाई वी हैव नॉट एडेड। Calculate and tell me what is the answer, the last answer.
7.82 into 10 raised to 4.
7.8,
Yeah,
7 7 49 and 7.8 आ रहा है आपका, ठीक ठीक है, 7.82
yeah.
फॉर ATM, ठीक है, करेक्ट है।
Sir, could you show the starting part also again?
हाँ श्योर श्योर। Done guys, yes or no, please tell me. Maimuna, Abdurrahman, Salman, Saif.
Done.
Done, sir.
Now let's write applications of Henry's law. Applications of Henry's law. So the first application is that if you see the carbonated drinks, na, soft drinks, hai na, so या फिर soda, so it has CO2 dissolved in it, right? And in order to increase the solubility, that means in order to increase the amount of CO2 that can be dissolved inside, that can be dissolved in the solution, what we do, we seal the bottles in a very high pressure. So what happens with high pressure? With high pressure, more and more CO2 gets dissolved in it, right? To increase, first thing is that to increase the solubility of CO2 in soft drinks and soda water. And soda water, what happens? The bottle is sealed under high pressure. Okay, what happens with high pressure? Due to high pressure, the solubility of CO2 increases. Okay, is that right? Yes or no? Please tell me. No doubt still here? Any doubt till here, guys?
No, sir.
No, sir.
Okay. ठीक है, इसको जल्दी से लिखिए. Now the next one. Don't draw what I am drawing. Are you done with the first point? Yes or no? All of you done with the first
Yes.
point, Anna? Okay. So now you will tell me, what do you think? Where will be the least pressure at the position 1, 2 or 3? सबसे pressure कम कहाँ पे होगा? ये sea level है आपका. This is your sea level. This is deep inside sea. And this is in the mountainous region. Mountains or hills. जी. What do you think? Where will be the pressure high, lowest बताइए, सबसे कम कहाँ पे होगा? Acha, okay, someone has answered me. Salman is saying 1. Okay. ऐसे assume करते हैं. All of you are facing some kind of pressure right now, yes or no? Physical pressure.
Yes, sir.
What is the physical pressure that you're experiencing right now? What is the value? कितना प्रेशर है? नॉर्मल प्रेशर कितना होता है? 1 atm ना? अरे कहाँ खोए हुए हैं?
Yes.
Yes, sir.
All of you are experiencing 1 atm pressure. 1 atm pressure. अच्छा, वो 1 atm कहाँ से आ रहा है प्रेशर? कौन एक्सर्ट कर रहा है? एटमॉस्फेयर, राइट? है कि
Yes.
नहीं? तो होता ये है कि the atmosphere we have gas particles, right? Gas, it has mass. Earth, it has mass. There is gravitational pull from the earth. So gas particles, they exert 1 atm pressure. ठीक है? तो अब ये देखते हैं. If you will have more air above yourself, then there will be the pressure will be higher. If you have less amount of air, the pressure will be lower. So let us see the amount of air that is present in each cases. So in the sea level, you can see that the amount of air that is present is this much, right? And if I look at the mountain region, then the amount of air that is present is higher or lower than sea level? Tell me. कहाँ ज़्यादा है? Sea में या mountain में? कहाँ पे ज़्यादा है air? बताइए. Sea में या mountain में? अरे, where you are experiencing more air in sea level or in mountain? ये भी जवाब नहीं दे पा रहे हैं आप. माउंटेन में ज्यादा एयर दिख रहा है आपको. बेवकूफ हैं क्या बिल्कुल आप लोग? नहीं दिख रहा आपको? यहाँ ये अमाउंट ज्यादा है ना. अरे कैसी बातें कर रहे हैं आप? जो हिल है इतना तो आप फेस ही नहीं कर रहे हो. क्या हो गया भाई आप लोगों को? विच इज हाइयर, ये बड़ा है या ये ज्यादा है? कौन सी ज्यादा है? सी लेवल ना.
C.
क्या दिमाग में पहले से बैठा के रखा था आप लोगों ने कि माउंटेन में प्रेशर ज्यादा हो जाता होगा? नहीं होता भाई. माउंटेन में विल हैव लेस प्रेशर. इज दैट अंडरस्टूड? यस और नो? प्लीज टेल मी. क्लियर है ना?
Yes.
Yes.
सलमान, है ना? ठीक है, चलिए. So we will say that 2, that means mountain or hills has the lowest pressure, followed by 1, that is the sea level. अब जब आप समुद्र के अंदर चले गए हो, when you are inside the sea, inside the ocean, then you have this waters, right? The water will also exert some kind of pressure, right? And you will be facing the most pressure at position number 3. Yes or no? Please tell me. Clear है?
Yes.
ठीक है. देखिए, we are accustomed to what? We are accustomed to this level 1, है ना? We are accustomed to the sea level. We are accustomed to sea level. Here we have 1 atm. इससे हमको कोई परेशानी नहीं है. But if I become a climber and I start moving upward, if I start moving upward towards the hill, then what I will be experiencing? I will be experiencing pressure that is less than 1 atm. And if I become a deep sea diver, no, I have dived inside the sea, and I'm at point 3, that at this point the pressure will be higher than 1 atm. तो जब प्रेशर 1 atm से कम होगा तो जो चीजें डिसॉल्व होनी चाहिए थी, the things that you should be absorbing in the blood, that will not get absorbed. जब प्रेशर 1 atm से ज्यादा होगा तो वो चीजें जिनको एब्जॉर्ब नहीं होना था वो भी एब्जॉर्ब होने लगेंगी. ठीक है? So what do I mean by that? So if you are having pressure that is lower than 1 atm, then O2 is less soluble. O2 is less soluble, and if O2 is less soluble, so no matter how much you are breathing in, less oxygen will be soluble inside the blood, and the blood will not carry the O2 that is required. The blood will not carry the oxygen that is required. So next point जो हम लोग लिखेंगे, that is when you are at high altitudes. Second, right? The second point, at higher altitudes, the pressure is low, and hence the solubility of O2 in blood decreases. O2 in blood decreases, which results in lower concentration of O2 in blood, causing weakness and dizziness. and dizziness. Okay, the condition is known as anoxia. Okay, so this is very important point. CBSE has asked this multiple times. What happens at higher altitudes? चलिए, please write this down. Second point. फिर third point में समझते हैं कि कौन सा ऐसा गैस है जिसे डिसॉल्व नहीं होना चाहिए था. 1 atm में it is not getting dissolved at 1 atm, but when you increase the pressure at deep sea levels, then what happens? It gets dissolved. Okay. Write this down. Second point. Let me know when you're done. No doubts now? Yes. Abdul Rahman, Khalid, Maimuna. No, na? Sam?
No, sir.
Okay.
No doubts.
ऑल्टीट्यूड सिकनेस भी इसको कहा जाता है, ठीक है, और ऑल्टीट्यूड सिकनेस. डन है? ऑल ऑफ यू डन? यस और नो? यस, आगे बढ़ते हैं. ठीक है. थर्ड पॉइंट. ठीक है, वी आर एक्सप्लेनिंग दिस. अभी इसको लिखने की जरूरत नहीं है. डोंट राइट दिस. ओके, डोंट राइट दिस. सो normal air is what? Normal air is generally nitrogen and oxygen, right? Most of the content is nitrogen and oxygen. Yes or no? Please tell me. Air, atmosphere में,
Yes.
Yes.
है ना? So in order to mimic it, when you have the deep sea divers, they have gas cylinders. They have gas cylinders, and in order to mimic the atmosphere, the gas cylinder was initially composed of nitrogen and oxygen, N2 and O2. ठीक है? So at sea, पहले आप sea level पे रहिएगा. At sea level, then you will be inside the sea, and then again आपको बाहर भी तो आना. Then you will be coming back, right? Come back. 3 प्रोसेस है यहाँ पे. So while you are having that cylinder at sea level, it is fine, normal. ठीक है, it is normal. But as you are moving inside the sea, what is happening? The pressure is increasing, and as the pressure increases, what happens? Solubility of N2 increases. ठीक है, because pressure is increasing, even though at 1 atm pressure it was not soluble, but if I increase the pressure, it is getting soluble. Solubility of N2 increases. Now you have in the bloodstream, you have nitrogen molecules here. You have nitrogen molecules. ठीक है, in the blood. With the blood also you have nitrogen. Okay. Now what happens next? What happens? Now you are coming back, right? So जब आप वापस आएंगे तो क्या होगा? Pressure decrease होगा. Pressure decreases. Pressure decreases and N2 leaves the bloodstream. N2 leaves the bloodstream. And if something leaves an occupied space, then what you will be getting? You will be getting a bubble. है ना? Vacuum create हो जाएगा. You will be having a vacuum inside the bloodstream. Okay, you have this bloodstream here, and in between you will be having some kind of vacuums like this. These are bubbles. Now these bubbles, they will restrict the flow of blood, and when they restrict the flow of blood, wait a second. Okay, when you have bubbles, what will happen? They will restrict the flow of blood, causing again what? When the blood is not reaching each and every part, you will be feeling weakness, right? You will be feeling weakness, and the reaction time that you should have, that will also lower down, right? So आपको थोड़ा सा, you will be reacting slowly at that time. Now this condition is known as bends. This condition is known as bends. Okay, so this is the at sea level. Normally what happens? Inside the solubility of N2 increases, and after when you come back, what happens? N2 leaves the blood and there is bubbles form. So we'll write that. What can you write? You will write that when deep sea divers come back to the surface of water, the N2 in blood leaves as the solubility decreases, which leads to formation of bubbles and causes and restricts the flow of blood liquid transfer and restricts blood flow. Now, in order to deal with this, this condition is known as condition, क्या बोलते हैं इसको, बेंड्स बोलते हैं. Condition is KA. KA का मतलब known as bends. ठीक है, ध्यान रखिएगा इसको. The condition is known as bends. In order to deal with this, helium is also added as it has very low solubility and also one more reason is that helium is small size, very low solubility and small size. ठीक है, small size से क्या मतलब, low solubility का मतलब आपको पता चल रहा है that even if you are at a very high pressure, it is not going to get dissolved, and even if it gets dissolved, it is having a very small size, right? It is having very small size, and when you come back, you will be forming some bubbles, but these bubbles will be very small. These bubbles will be very small. Okay, so that is why helium is used. The general approximate composition will be composition of the gases is generally 12% is helium and 32% is O2. N2 फिर कितना हो जाएगा बताइए? N2 will be 56, I think, ना? हाँ, 56% will be N2. Okay, so this is the composition of gas cylinders, approximate compositions. Okay, accurately speaking, I think it is 11.7, 32.1, 56 point something. है. चलिए, please write this down. ये समझ में आया सबको है कि नहीं? Please tell me. All of you understood this point? Yes or no?
Yes, sir.
अरे हाँ ना.
Yes.
Okay. Scroll up. Okay. इतना धीमे से कौन बोल रहा है भाई? Is everyone done? Please tell me yes or no.
Yes, sir.
अच्छा, आई हैव गिवन यू मेनी असाइनमेंट्स टिल नाउ। आप लोग को उसमें किसी में डाउट है तो बताइए, क्योंकि सैटरडे को फिर आपका टेस्ट है ना कंसंट्रेशन टर्म्स का। अभी तक जितने भी असाइनमेंट है सारे में कंसंट्रेशन टर्म्स ही है। सो अब्दुर्रहमान, खालिद, मैमूना, सैफ एंड सलमान, टेल मी इफ यू हैव एनी डाउट्स इन एनी ऑफ द क्वेश्चंस असाइनमेंट्स के। ये अभी तक तो मिला नहीं है हमको असाइनमेंट जी। यस अब्दुर्रहमान। अब्दुर्रहमान आपने किया है कि नहीं असाइनमेंट्स को? I can't hear you. Khalid, what about you? Khalid?
Sir, what is the latest one, by the way? Normality one, right?
That will be, wait a second. नहीं, नॉर्मैलिटी वाला तो उससे, नॉर्मैलिटी न्यूमेरिकल्स तो उससे पुराना है। उसके बाद हमने एक और असाइनमेंट दिया था, that was uploaded on Tuesday, that must have been uploaded on Tuesday, that was solubility of solids in liquids.
Oh,
That
yeah.
expires tomorrow.
हाँ नहीं, आई नो। ये बताइए कि उस किसी में डाउट है अभी तक के असाइनमेंट में तो बताइए। If you want me to do a few questions जिसमें से आपको लग रहा है कि नहीं हो पाएगा आपसे, तो वो बताइए, and I will explain those. Maimuna, what about you?
Yes, sir. I tried those questions. I didn't find anyone difficult.
Anyone difficult? No? Okay. Saif, what about you? Saif,
Yes, sir. Done.
आपने किया असाइनमेंट? नहीं किया है? क्या किया है?
I did it.
No doubts?
5 minutes, sir. I will check and see.
हाँ देखिए प्लीज देखिए। Maimuna, how is your haloalkane halorine going on? स्कूल में समझ में आ रहा है वहाँ पे?
Yes, sir.
Yes, sir. No doubts.
No doubts. सलमान, आपको भी कोई डाउट नहीं है?
No, it seems simple.
ओके फाइन, चलो। सिंपल नहीं, करके देखिए तभी समझ में आएगा उसमें, ठीक है? छोटे
Yeah, I
छोटे
will.
सवाल रहते हैं। हाँ ठीक है, चलो। ओके गाइस, टेक केयर, बाय। एंड अगेन संडे एग्जाम है, प्लीज प्रिपेयर, ओके? प्लीज प्रिपेयर। सैफ इज न्यू, राइट? अब बाकी सभी लोगों ने तो ऐप में एग्जाम दिया हुआ होगा ना, पहले टेस्ट तो दिया होगा। खालिद, अब्दुर्रहमान, मैमूना, सलमान,
Yes.
है ना? यू ऑलरेडी नो। सो सैफ, अच्छा जस्ट करेक्ट मी इफ आई एम रॉन्ग, है ना? सो ऑन संडे एट सम टाइम द टेस्ट विल बी अपलोडेड and most probably it will be of half